So we're going to be talking about the Pythagorean Theorem. And the Pythagorean Theorem is a theorem that we use with right triangles to actually determine relationships between sides, being the legs, the two legs of the right triangle, which form the right angle, and the hypotenuse, which is the longest side of the right triangle. And what I'm going to do today is I'm going to explain to you how to use the theorem, and I'm going to show you its origin, where it came from, and why it works. Most of the time when you guys are asked what's the Pythagorean theorem, you spit out a squared plus b squared equals c squared because you've been conditioned. That is your response. A lot of times, however, students don't know what that means exactly. They don't know what a and b and c are, and they don't understand why you're squaring them. So I'm going to actually show you this. But let's look at the theorem itself first. So on this page, you can see this is your notes page, that we have two of three sides of a right triangle are known. The third side can be found using the Pythagorean theorem. Pythagorean theorem is the square of the hypotenuse is equal to the squares of the legs of the triangle. So I have this box here for you. In a right triangle, the two legs are the sides that make the right angle. You can make an L there. Think about the word leg being spelled with an L. So the two sides of a right triangle, because that's what a right triangle is. It is a triangle that has a right angle. And if you guys don't remember, a right angle, when you see this little box, is a 9-degree angle. The hypotenuse is this long side. So this is your hypotenuse. Okay, that's your hypotenuse. And the Pythagorean theorem says, as you can see above, the hypotenuse, when you square it, is equal to the sum of the squares of the two legs. And the way that we've always seen that written is we've seen it written a squared plus b squared equals c squared. And understanding the origin of this theorem will really help you understand why it works. So let's go over to a different document here. On this particular page, what I'm going to show you is I'm going to actually show you why the Pythagorean theorem works. And so let's go ahead and put this at the top, just as our reference. We said that the Pythagorean theorem was a squared plus b squared equals c squared. And let me go ahead and add in the operators here. So a squared plus b squared equals c squared. The question is, why does this work? Why does this work? Well, let's check it out. I'm going to draw a right triangle. And remember, a right triangle, by definition, is a triangle that has one right angle. And I'm going to label the legs of the triangle. I'm going to call this leg A. And I'm going to call this leg B. And I'm going to call this leg C. And now that I've done this, I can see where the a, b, and c come from. The a squared plus b squared that you're seeing here is if I take the length of this leg and square it. Remember, squaring also means putting to the second power. So a squared means a to the second power. And I add it to whatever the value or the length of this leg is, b, squared as well. If I add those two guys together, then that's going to equal the length of the hypotenuse squared. Now the question is, why does this work? Why does this a squared plus b squared equals c squared work? Well, it's actually based off of squares. And, excuse me, coughing, COVID. If I were to take each side of the triangle and I were to extend it out and draw a square. So I'm going to draw a square here. And since this is a square, what does that mean? That means all these sides are the same, right? So that means that this square is an A by A. Now, if you want to review, and let's come over here and we'll review. When you have a square, that means you've got four right angles and all four sides are congruent. What is the area of a square? Well, the area of a square, if this is the side of your square, is side times side, which would be side squared, right, to the second power. So what's the area of this square? What's an A? And I'll use my cursor. What's an A by A? Well, the area of this square would be A squared. So I'm going to come over here and I'm going to draw another square off of this one. And again, I apologize for my graphics. And we're going to make this another square. And I'm going to put all these boxes here so you can see that this is a square. I'm going to put my little tick marks to show all these are the same. And this square is a b by b. So what's the area of a b by b? B squared. And if you're still a little confused on what I'm doing for areas, let me give you a better example. If I give you a square and I tell you it's a 5 by 5, what's the area? 25. How did you get that? 5 times 5, which is also 5 squared, which is where I'm getting these values, okay? So now I'm going to draw this final square here. And this square is the biggest of all because it is the same length as my hypotenuse, which is the biggest side of my triangle. And if this is a square, what's the area of a c by c square? C squared. So what the Pythagorean theorem is telling us, in fact, is that when you have a right triangle, if you take a square that has the side lengths of one of the legs and find the area of that square, and you take a square that has the side length of the other leg, and you find the area of that square, and you add the area of these two squares together, it equals the area of this square. And I'm going to give you an example using real numbers. So let's scroll up a little bit, and I'm going to give you another example with real numbers. So let's draw our right triangle. And I'm going to give you a classic right triangle. A classic right triangle. This is one of the Pythagorean triples you'll be learning about, sorry. Not losing about. That's what happens when you have COVID brain. So let's check this out. If I were to make a square out of this, what is the area of a 3 by 3 square? 9, right? 3 times 3 is 9. Everybody can agree? If I were to make an area, a square out of this one, this square would be a 4 by 4. So what would the area of that square be? 16, right? Well, my final square is going to be my hypotenuse. And this is going to be a 5 by 5 square. And what's the area of a 5 by 5? 25. Well, let's check this out. The area down here, 9, plus this area right here, 16, should equal the area of this, right? 25. And if you check it out, 9 plus 16 does in fact equal 25. So this is the whole premise of the Pythagorean theorem. It is just basically adding areas of squares together. So let's jump back over onto the notes. So back over here, we now know what a squared plus b squared equals c squared means. We're talking about areas of squares. So, sorry, let me erase that. I'm going to go ahead and scroll up and let's do some examples. So here, we're missing the hypotenuse and we need to find the hypotenuse. So we're going to use the Pythagorean theorem and I'm going to give you the colors. I'm going to color code it again. We've got a squared plus b squared will always equal c squared. And you have to figure out what you plug in for a, b, and c. Now we know a and b are the legs, so these guys are going to be the legs. Does it matter which one's a and which one's b? No, it does not. You can plug in 3 and 7 in either order because a and b are interchangeable, okay? So I am going to go ahead and just make 7 my a, so I'm going to have 7 squared. I'm going to make 3 my b, I'm going to make that b squared. And I'm going to make c my c, and that's just going to be c squared because I don't know what that guy is, okay? And you can look at me, I'm already scatterbrained here. Sorry, let me fix that. That'll be 3 squared. So now, again, calculator math here. I'm going to go ahead and just solve this out. I've got 49 plus 9 equals c squared. And if I combine these guys down here, 49 plus 9, that's 58. And that's equal to c squared. But here's the thing about the Pythagorean theorem that everybody forgets. I don't want c squared. What am I looking for? C. So how do you undo squared? You're going to take the square root. So I'm going to take the square root of both sides, and I'm going to come over here. The square root of c squared is actually just c, and then we will do the square root of 58, and we get 7.6. So c is actually 7.6. We haven't done solving radicals yet. We'll get to that. That's something where we will work with radicals and reducing radicals, but right now just get the decimal answer. Okay, let's look at example 2. Example 2 is the same scenario. Again, a squared plus b squared equals c squared. I'm going to write this ad nauseum, which means until you're sick of it. I believe it's a Latin term. And we're going to plug in. So it doesn't matter which of your legs is a. I'm going to make 6 my a. So I'm going to have 6 squared. 8 is going to be my b. That'll be my... And then c, I'm looking for c, so c squared. And it's not always going to say c. Your variable could be x, it could be j, it could be k. It's not always going to say c. We're just doing this to make it easy for you right now. So that's 36. 8 times 8 is 64. And then I've got my c squared. So now I'm going to add these guys together. 36 plus 64 is 100 equals c squared. But again, I don't want c squared. I just want c. So to undo c squared, I've got to take the square root of both sides. And so that's c. And the square root of 100 is 10. So that is your answer. So this gives you a good idea of how you can solve to find the missing pieces, okay? Let's look at the third example here. The third example kind of gives you a practical application. Once again, we've got a square now, and it's asking you to find x. Well, what can we divide a square into? If you look at the square carefully, we can divide a square into 2 right triangles. So that's basically what you have. So we've got right triangles here, and we want to find the diagonal, which is really the hypotenuse. So we're going to take this square apart. But before we do that, what do you know about a square? All 4 sides are equal, right? Sorry. They're all the same. So I'm going to chop off one of those triangles. And let's do it this way. We'll chop off this triangle here. That's 4, and that's 4, and we're looking for x. So once again, I've got the Pythagorean theorem. What's my a squared? I'm going to make that 4, so 4 squared. My b squared, well, in this particular example, a and b are actually the same because it's an isosceles triangle, equals my c squared. And in this case, what is c? X. So it doesn't matter what your variable is. Your variable can be anything. You just have to know how to set these guys up. All right. So 4 squared plus 4 squared gives you 16 plus 16. And again, calculators are wonderful things. I'm going to work this out by hand so that you get used to seeing the math because you need it. And so you get 32 equals x squared. But again, I don't want x squared. I just want the x. So I'm going to square root both sides. And so x equals, and then you go and you take the square root of 32. And I'm going to actually find the actual one without doing simplifying. And it is 5.7. So your answer is 5.7. So that is how you do the Pythagorean theorem when you are solving for a missing side or a missing hypotenuse.